Welcome to a radio telescope observation party for February. And the couple things going on. We are shifting servers for our website, and that should be completed here in the next couple of weeks. We may get a disruption in service in the store and a couple things, but we're working on it. Didn't have a choice. I think that the old host, something, they either went out of business or whatever, they're going out of business or something. Chip is working on that. We also, it's time to sign up for your Western Conference. If you're going to be online, it's $15. You sign up at the store. If you're going to show up, it's $55, and that's just for the lunches and things like that. That's in Socorro, New Mexico. And sign up now so we can figure out. There's also on the website and on the last journal was the hotel that we've got special rates for, and you might try to grab a hotel room there. We will be driving a lot. We're not going to have buses or anything to the site. So in Socorro, they've got the actual Dimitry Center where the conference is. We got a big room in there. And then one day we're going to drive out to the site. And I think there's actually a second site that I've never been to that Jason, our current new resident professional astronomer, has found that he says about 40 miles away from the primary site that he said would really be good to go to. So there might be that. The schedule is coming out. Will be by this week. Ken is working on that, and so far so good. But I think we probably don't have enough online guys. It'd be nice to know who's showing up online. So please sign up as soon as you can, just so we can get our counts. And okay, last but not least is the journal. I need inputs by the 12th in order to get it out by the end of February. Because when we do the journal, I basically accumulate everything by the 12th. It takes me about a day because I'm editing along the way. I think about a day to get that thing set up. But then I send it to the board of directors, who then review it. And they give me all sorts of editorial comments or comments about the contents of some of the stuff. And we have a discussion about that. And then I give them about 5 days to do that. And then when they're done, I spend about a day fixing, and then I publish it. So it takes about a week from the 12th. So the 19th is about average for me to get it out when I give you guys the 12th. I could use some more articles. I don't have very many observation reports. So I'm seeing the M33. Everybody's doing M33. They're doing all this other stuff. A lot of discussion about waveguides. If you guys want to just put a couple page things about your M33 results, this waveguide discussion is excellent. Somebody put a summary about that together. That'd be wonderful. Anything that's on that listserv is legitimate to go put a quick report in the journal and document it. That'd be very nice. Okay. That's all I've got. And Mike, why don't you start again and tell us what your group's doing with the YouTube channel, and also you just did a sky and telescope article too, and tell us about that. You're on mute.
Unmute. Mike, okay, there we go. So the latest sky and telescope, March 2025, it's out now. And then they have the article on my experience of building and using the itty bitty radio telescope. And they actually did a pretty good job. Sarah's in here a bunch. And that that was fun to see and do. I pitched an idea to Sky and Telescope, and I don't know if they're going to accept it or not, but I've built 4 different antennas now over the last year after the itty bitty meteor detection, 21 or scope in the box, and super SID. And I pitched an idea to Sky and Telescope to possibly write a feature article on the process of building all of those. And we'll see. They haven't said anything yet. I don't know if it'll go, but it'd be fun to just walk through that. So that'd be, or to do something like that. So we'll see if they want to do that or not. And then the other thing, so RCA, which is Rose City Astronomers out of Portland, I actually live in Bend, Oregon, but Rose City Astronomers has a pretty big footprint. It's a pretty big club. They got 800 families in there. Quite a lot of seemingly pretty skilled people, some professors and whatnot, and they bring in some high-end speakers. So anyway, they have not had a radio astronomy wing. And so I pitched an idea to one of the other guys there saying, hey, why don't we start one of these, or a radio astronomy special interest group, they call it, SIG for short, a radio SIG. And we had our first meeting last week. When was it? Last week before? Last week meld together, but anyway. But it went really well. We had, I think, 15 to 20 people that were in the SIG and some pretty skilled people. And then we also took on another thing, and that I mentioned previously was to build in conjunction with the Portland State University Engineering Department, their students have to do a capstone project. And we've got 5 pretty good students working on putting together a radio telescope for us that we would mount at our site in the Central Oregon area. So that's working. So a lot of things happening in this area. Fun. So that's it. We'll see where that radio special interest group goes, and I'll let you know about the article if Sky and Telescope really wants to do it or not. So yeah, it's fun stuff.
Boy, excellent.
Yeah, that's my story, and I'm sticking to it.
Excellent.
I've actually learned a few things over the last year.
Anybody got any questions for Mike? All right. I'm just going to go by time zone here. Rob Lucas.
Hey, Rich, I did want to mention one thing. I'm going to have to drop out here in about 10 minutes. And so I just wanted to let you know that I was doing that. And if I go off screen, it's not an objection to anything anybody has said. It's just a planned event.
No, we're very proud of you, Mike. Thank you very much.
Thank you.
Hey, Rob Lucas, you there? All right, he might just be off here for a second. Let's see. Andrew, you said you had a question for the group.
I keep forgetting to turn on the microphone. You also said I needed to have a presentation. So here we are. While you've all been talking, I've thrown something together. Is Alex here? Because I could really do with him being here. Is he here?
I don't see him.
Where's the guy when you need him? Anyway, there we are. I'm going to plagiarize some of his bits and pieces that he's been putting on the forum, which would be great if he'd been able to talk to it. But still, I'm sure he'll come back next time when he has a look at the video and say, I didn't mean any of that. Where are we? We need to get a somewhere around slideshow. Here we are. There we are. Basically, about 4 or 5 slides here. To start off with, there's this business of waveguides that was being discussed at the forum. Was started off as being my fault because I deliberately and provocatively deserve whatever I get back. Went to GPT and started asking it about waveguides. it produced some sort of what looked like superficially quite good suggestions in terms of the logic of it. And then came up with this idea, the WR650 waveguide, and even drew a diagram for a supposed waveguide. And then I went further in my sins and actually posted this both on the SARA forum and on the British Astronomical Association Radio Astronomy group. And then I got to say, people from SARA were very polite in that they didn't say very much. It just stimulated some more sensible discussion on the issue. But you should have read some of the posts that came from the BAA Radio Astronomy group. I don't think I've, in the entire time I've been doing radio astronomy, ever seen such unmitigated anger coming back from people. Not really holding their words too much. So, I suppose that is accessible through the internet these days. But there we are. Anyway, as I say, it wasn't directed at me, I should say. It was directed at ChatGPT. Anyway, although I put that stuff on as a sort of tongue-in-cheek, there is actually an underlying sort of serious issue from my perspective, which is that many people in this group have come back to me and said, how are you getting on with the solar cooker radio telescope? So for those who are unaware of it, so this is my second hydrogen scope, LROH2, which is Litchfield Radio Observatory, because I've given myself a fancy moniker for my shed at the bottom of the garden there. And so this is, again, following conversations that were on this group before, when somebody mentioned that on ebay.com, they were selling these 1.5 meter parabolic dishes like this, these petal dishes, and they were selling them as solar cookers. So you put your kettle in there and then heated it up from the sun, because apparently it could generate a kilowatt or something when the sun was shining on it. I looked on the UK eBay at the time and found that they weren't normally sold in the UK. Normally it was just the American ebay.com. However, somebody was doing a house clearance and had one of them for sale. Okay, £50, I bought one. So there he is, sitting there. It actually works quite well in terms of heating things up. I walked past it and found it rather burnt my my leg as I went past, and held a cardboard box at the focal point, and it burnt a rather nice hole through it. And that's in winter in the UK on one of our few sunny days. And they're not really very sunny, so it was quite impressive. I managed to find some cheap zinc aluminium spray paint, which is why you can't see a such shiny surface on there. And it's done a very good job stopping it from rusting. Anyway, the more important issue as far as tonight's conversation is concerned is that you can see there at the focal point, it is my attempt at making a Cantenna, which is an old copy tin. And it's got an N-type chassis connector on the side with a straightened paper clip on the inside, trimmed down to some measurements that I got from a calculator. And supposedly that was going to give quite a good way of detecting the Milky Way through hydrogen, but it doesn't perform particularly well at the moment. It will perform very well at all. And I've got to try and work out what the problem is. I do have a second one, which is LROH1, which is based on an ex-military array, and that is successfully mapping the Milky Way, and it's only a few yards away from this one. So I don't really know what the issue is. Poor Ted has had an email through this week with a whole pile of data asking if he could think of any ideas. I always go back to poor Ted every time I got problems and clutter his email inbox. Anyway, so that's my first slide. As I say, it stimulated some more sensible discussion about waveguides on the SARA forum. And so what I've done is just pasted a few of the or little bits of information that were put on there just to stimulate discussion tonight, really, because I wanted to ask people how they thought was the best way of going around designing a waveguide for my dish. For starters, ChatGTP had suggested one of these WR650s, and this is a square waveguide or rectangular waveguide, because you can have rectangular ones or you could have circular ones, it turns out, at least I've discovered. And these are apparently the WR650 is quite good because it covers the wavelength of 1420 very well. But you do get this sort of square metallic structure, as you can see at the bottom there. I did find a company, Radio Astronomy Supplies, who supposedly are selling these things in the US and charging $190 for them, but you can't buy them because they went out of business anyway, because the poor chap that was running it had really bad COVID and was in hospital for months over the pandemic, and since then has given up his company. Then on top of that, that conversation stretched. It's mainly between Alex and somebody else. I apologize, the other person's here on this group tonight. I couldn't find a minute ago just who it was. But anyway, most of the stuff I've got here has come from Alex himself, which is why he's put it on the forum. So he's brought this model for a 150 millimeter tube, as you can see here. I'm not sure. Again, somebody might explain to me in a second what a TE11 or TM01 mode is. I don't really understand what they are or what that difference that makes in terms of what we're doing in trying to map the Milky Way. Because that I noticed was in the conversation. People were talking about whether it was correctly getting the correct answer on those particular modes. Anyway, Alex posted this graph to the Cantenna. I suppose it must show the performance of the Cantenna. I'm not exactly sure if I understand what it means, which is I was hoping that he would explain it. And he also posted this suggestion for what we all might go looking for on eBay or elsewhere: a 6-inch by 10-inch long aluminium container. And again, so that sort of raised the question for me: what is the best size can to use to make a Cantenna out of? And does it matter what type of metal it's made out of? And does it have to be flared, or can it be straight like that, or do you have to put any extra bit on the end or anything like that? I found this on the UK ebay.com. So this looks, well, it's roughly a 1 gallon can. 1 gallon is about 4.5 liters, something like that. I looked up. We are nominally part of Europe, even if we've left the European Union. And so we still deal in liters over here rather than gallons at the moment. So this seems about that sort of size. But again, does that make much of a difference between having one of those things at that size versus the one that I've got, which I forget the size of? I think it was 110 millimeters at the end. Let's just say coffee tin. And how would I know how big to have the can or whatever to try and illuminate my dish? So I think I know this is, Alex posted this for an 83 millimeter tube again, but this T11 and TM01 mode. But again, I don't understand it, so I thought maybe somebody could explain it. Anything else? Oh, and he put a link to this calculator again on there. And that's me done. I don't know if anyone was able to give any insight into any of these things, I'd be greatly appreciative. Or do we wait until Alex comes back next time?
All right, you got any questions? There is I'm not sure if that's the same one that I've seen. There is another Excel Cantenna calculator, which actually has the TM modes in it, and it has you can put in the size of the Cantenna, the diameter, and the length, and it allows you to do all that and come up with the values.
So what's a TM mode?
Let me suggest something to you. There's a fellow by the name of Paul Wade, W1GHZ, right? W1 gigahertz, who has an antenna, especially a feed antenna and feed. It's actually a book, but it's available online, a PDF. You find that, and he has a chapter in there on a Cantenna feed. And he has measurements, real numbers, and he has dimensions, real dimensions, and a hell of a lot of great information on how you feed a dish, with other things as well, ring feeds, and I think other ones as well. And he has done an excessive amount, not excessive, can't be too excessive, but he's done an incredible amount of research on this. And
So what's his name again? Sorry.
Paul Wade, Wade, and his call is W1GHZ. Later on, while you guys are yakking, I'll stick I can find I'll find this thing and put it on the chat. But he's got the real dope on it. Now, the TM and TE, in a waveguide, these things denote, if you can imagine the electric vector, you know what a travel wave looks like in space, right? There's an electric vector and a magnetic vector, and they are at right angles, and they are perpendicular to the direction of propagation. And those are the ones that shake up the electrons in whatever thing you got to catch them. Okay. In the waveguide, TE means transverse electric field. That means that if you will, the vectors that denote the electric field are pointing into and out of the surface of the waveguide. In a cylindrical waveguide, transverse electric looks like a whole bunch of arrows pointing into the middle, the center. The center is a zero electric field point, and an electric field has to be zero at the surface of the metal. Okay, so that the TE mode is the one that you want to excite that little probe that you're putting in there, which is the thing that the electrons shake up when they go through the tube. The tube has a waveguide cutoff because, as you could imagine, the lower the frequency, the longer that electric vector looks when it's traveling through space. When it gets too big to fit in the waveguide, it won't shake the electrons in your little pickup anymore, right? The pickup distance from the end of the can and the length of the pickup are to be the quarter wavelength of the electric field that's traveling through, and they will be maximum excited by the electric field that comes through at the frequency you're talking about. When you prescribe a frequency for the can, has a wide acceptance from a wavelength that's too long to fit in the opening to a wavelength that is so short that it bounces around inside, and it's too short to essentially reach the center of the waveguide. It's a kind of crummy way of looking at it, and real electrical engineers would be beating me about the head and ears, but basically that's the way it works. So the dimension of the can, as people have pointed out over and over, for 1420, anything about 6 inches in diameter works great. And if it's at least, and the other thing you need to know is that the wavelength of, which is the distance between two successive zeros, crossings of that electric field, it is shorter in the waveguide than it is in free space when it approaches the thing. So you have to tune your little stub so that it's a quarter wavelength of the let's see, I think it's quarter of the free space wavelength. I'm not sure. Paul Wade will tell you. So that's about a nutshell thing. It's not difficult because there's an awful lot of jargon about it, and I suspect that's what your friends in BAA are, I don't know, tired of hearing. Frankly, probably. Yeah. I would look at that, and I would look at propagation in the waveguide. Now, the rectangular waveguide, now you can appreciate, is much sharper in its acceptance of the frequency coming in, because it's working on the wavelength it's working on is the one on the short side, not the long side of the waveguide. So that the electric vector as it comes in is pointing from on the short side from one side to the other. In the middle is zero again, right? So the probe that you stick in is again a quarter wavelength, and it sticks into the waveguide right in the middle toward the back. But rectangular waveguide is fussy. Now, as to material, you can actually use steel stovepipe, 6-inch stovepipe. Works very well. And I think Marcus has pointed this out, and some other folks. So that, in a nutshell, anything about 6 inches in diameter and about anywhere from 12 to 18 inches long is probably good. The other point about that is the so-called phase center, which is where the focal point has to go, is just a little bit inside the front lip of the opening. Not the post inside, but just inside the front lip of the opening of the can, and right in the center. And boy, you got to find it. So you use your solar, you put a piece of paper across the can, stick it in there, and use your solar to find the center and make sure that it's right in the center of the can, because otherwise it won't excite the waveguide properly. So that's about how you set about doing it.
Oh, thank you very much indeed. That's wonderful.
I hope it's clear. It may actually be on the, oh good heavens, we're being recorded. How many uhs did I put in already?
I'll take them out. I gotta think for that. You're good.
Okay, take care of the.
Can I
take care
make a
of the
couple of
uhs.
quick comments? I think Don's
Absolutely,
explanation.
and if I've missed anything, please remark on it, because I'm not that good at impromptu.
I think he did a very good job of explaining that, but just a couple of quick comments. The graph that Alex showed you, what he was trying to show you, I think, was that 750 megahertz signal fell outside the cutoff range of the waveguide, because the waveguide acts as a filter. And the
Yeah.
other comment I have is the can is actually a waveguide, so to speak, also. So it's going to
It
have
is.
some of the same characteristics.
The can is a waveguide. It is exactly a waveguide.
So
And
all the information you read in Paul Wade's website would apply to your feed horn or your can also.
absolutely, without question. No, Paul Wade's he treats a cantenna. He's got a chapter in there on a cantenna. And don't be overawed by the drawings and such, but read carefully what he has to say, and I think it will make sense to you. The thing to remember is to read somewhere the basic definition of what a radio wave looks like as it travels through space. And we're paying attention. The transverse electric and transverse magnetic will get you all screwed up. But the idea is this, that at the surface of a conductor, the electric field must go to zero. It terminates on the surface. The other thing is that on transverse magnetic, the magnetic field is always a pain in the butt. And the reason is that it cannot terminate. Magnetic fields have no charge. You can't terminate it on a charge. So it does funny things at surfaces, and you don't really want to know about it. Forget it. Work with the electric field and be satisfied. Okay? But you're absolutely right. The can is the waveguide. That's the point. That's the whole point. And it's the reason that you can use it as an antenna feed quite successfully. They're very successful. People seem to have trouble with them, and I just don't know why, but that's it.
I think the problems people had with these things is that they don't have the focal point of the antenna just inside the lip of the cantenna. And that's
Right.
usually, if you got it built, if the cantenna is built right and you think you did it right, the problem is you probably have to move it up and down until you find where the focal point. You probably have it deep or or shallow. And if you put little mirrors along, of course, along there, you can actually probably get, find out exactly where the focal point is
Right.
with little mirrors. The other question I had, Don, is Andrew, you showed a bucket shaped thing, higher diameter on the top and lower on the bottom.
No,
I don't think that'll work. It has
no,
to be
you don't
straight.
want tapered. You can do that. You can do it, but what it will do is it'll screw up the simple probe as an efficient way to capture the traveling wave in the can.
Right.
It's got to have straight sides. Well, it
Yeah, that's
doesn't gotta have. That's the point. None of this stuff has to be, but the trouble is, what you're looking for is the best fit and the most efficient can to capture the paint, so to speak. So you really need straight sides, and you really got about 6 inches diameter. Try and find some that there actually is stainless steel. Oh, that's the other thing. It would be best if you could find enough silver to build your can out of. However, or gold would be even better because it's an even better conductor. But I don't think a gold can would be. I think your neighbors would probably have it before you got any radio waves through it. Aluminum is better than steel, but steel will work. And brass is in there in between. Copper, actually, it would be copper, aluminum, and steel. Copper, brass, aluminum, and steel. But copper and brass are expensive and very hard to work with, and you can't buy tubing that won't break your bank. The best thing to do is to find some stovepipe. Go rob a good Victorian chimney.
I successfully used a cardboard coffee can and coated on the interior with copper tape.
Foil. Yeah,
Copper tape, and that worked fine.
Copper tape. Yeah, copper tape will work. That's tricky too, but yeah, it'll work. Copper tape will work.
I think the other thing I noticed that I remember from Alex's talk, that 750 megahertz cell phone signal was really bugging him, and he couldn't figure out a way to filter it. But he was able to filter it by lengthening that coffee can,
Yes,
which provided a filter at the 750 megahertz. You don't have to have it that long, but he actually had it that long because he was trying to get rid of that cell phone, and it worked. So that's the other thing. That length is a filter.
The length is a filter, and you could actually run it out to 18 or even 24 inches if you really wanted to. But the phase center, the place where the focal point is, still just inside the front. Okay, that's the important thing to remember. It's about a couple actually, it's only a couple millimeters if I remember right. And the way to find it is the first thing you have to do is to make sure that the focal point that your can is on the focal line of the antenna. In other words, it's at right angles to the antenna plane. And the other thing is you find the center first, and then you proceed to move the pipe up and down that center just a little bit inside, and you'll find the optimum place. It's going to take a while. Use the sun. You won't hurt if you're disconnected from your, even if you're connected to your preamp, it won't really hurt it. But the best thing to do is go out on a sunny day, disconnect the preamp, take it off. You can't hurt the probe. Don't forget, you're looking to put the focus just inside the center of the front of the tube. By the time it gets to the back of the tube, it'll be bigger and it won't be heating it so much. Or you can put your lunch in there and cook it if you want. But the thing is that you should put something across the surface, get the thing so that it's collinear with the focus, and get that focal point to the center. Now you appreciate that it's important that if you draw an imaginary center line in your can, that it be on the line of the focal point. It's hard to put. It's the axis of the parabola. It's important that it be collinear with the axis of the parabola and right on it. Otherwise, you'll get distortion. You can imagine in your head, if you start to twist that so that it's pointing somewhere else, less and less is getting in and more ground noise is getting in. And eventually you won't see anything but ground noise. So you, in extremis. So the thing is, you've got to make sure those things happen.
Okay, and Ted just put a bunch of links to Cantennas and everything. Andrew, my guess is you just need to go slide your feet up and down a little bit.
Yeah.
And find the happy place.
Put a piece of paper across the front and use the sun.
Will do.
It's a perfect thing to use, especially for that size dish. Really big dishes, it's a different problem because the sun is a finite source in size, and so you got some other problems. Ted, did you find Paul Wade's treatise
on my chat?
Paul?
I think I did. You take a look. Bye-bye.
See if you found Paul Wade's thing on chat, as long as you're so good at doing that. I can't believe it.
You study them. I think I did. Even the chat.
Great. Good.
Okay. All right.
Okay.
Let's shift gears a little bit.
Well, thank you very much indeed. Really appreciate it.
I'm sorry for being a nanny, but that's the way it is. It's been a friend of mine, Elon Musk, says the law, physics is the law. Everything else is a suggestion.
Okay, I'm going to get to Rob Lucas. Rob, you there?
Yep, I'm still here.
All right.
Haven't done too much. What I have done is I've put together a network time server and was able to use a GPS and get within a couple nanoseconds of real time. And interesting, it's basically a basis for, I'm doing the routine, aren't I? Anyway, it's a basis for the interferometer timing, see if I can make that work. So that's where I'm at.
I should have never mentioned that because everyone's going to be very self-conscious about it now. But I will take it out.
Okay.
Just realize that. So the software takes out all the uhs and ums. So anyway, let's get to Dimitri. He's the next time zone guy.
Hi to all. I'm not be too long today. I am preparing papers about W75M observation 6.7 gigahertz for journal January, February issue and conference paper for Western Conference.
Dmitry, you're cutting in and out a little bit. Oh, here we go.
Quite spectrums. This is for first half of November. This is typical view of spectrum from Japanese Ibaraki I-mate database. This is quite spectrum, but I have at least 2 of them. But next spectra show some variability and disturbances in this measure. This December spectrum, so second half of December, and January spectra became narrow, and also I obtained narrow line about 4 kilometer per second. Some bumps in about 10 kilometer per second. I'm not sure that this bump is this bump come from real radiations, and because of all levels is about my threshold of detections, 80 Mediansky, and they can be artifact of post-processing, but can be real radiations. And in previous spectra, this line is possible for this measure. I have several disclaimers I will make several disclaimers about this situation in papers I prepare now. This spectra is very recent, very fresh. Surely to say that something in this measure is changed, and there are some dramatic changes in this star forming regions W75N. I am not sure that all lines are real and not artifact of pod processing, but surely that something in this measure is changed, and some dramatic changes there. Thanks. That's all for now. Thanks.
All right. Any questions for Dmitry? Thanks. Good stuff. Let's go.
Thank you.
Ted, let's go to you.
Very good. I'm pushing buttons here. Okay, I'm thinking, oh, I gotta come over here. There we go. So there's a long title, Ezra Stereo Island Movie. So it's something about Ezra, that software I keep working on. Something about a movie, something about an island and stereo. Wow, okay, let's take a look. I keep playing with, we have complicated data and how best to represent it all. This kind of plot might be familiar to you already. We have samples stacked up like vertical books from left to right, increasing in time, and then each sample has frequency from a low number at the bottom up to a high frequency at the top. And we see over a course of a day this interesting pattern. There are two bright spots where the antenna happened to be rotated by the Earth to look at the galactic plane. Okay. There are ways to improve some of this. There is a line down the middle here that I don't like. And so perhaps the software can remove that by hiding that data. So that makes it a little bit better. But gosh, all this stuff in here is blue or purple. There's a lot of noise going on. So it turns out if Ezra EasyCon, one of the programs, has a way now to smooth the data to try to remove some of that noise. And that seems to help the contrast. So that's an improvement. Good. And then we can plot this using this 3D plotter program and to see the same thing. But it's a 3D program, so we can plot it at a slightly different angle, or even down here, or even way down here. So that's fun. We're starting to see the data in a different light. In fact, we can move the camera a little bit to the right, and even more to the right, all the way around to the side, so that we're actually looking at the graph now from the right side, looking at it. And if we squeeze the data in and out of the screen, we can actually make it smaller, smush it down even so that it becomes flat, and we get to see all those spectra lined up, piled on top of each other. That's interesting. And then we can put labels on it to get all the values. But part of the Ezra process is to remove frequencies we really don't care about anymore. And sure enough, over on the left, there's a whole bunch of frequencies we don't need. Let's change the range that this 3D plotter concentrates on, focuses on, and removes that data so that we start a little bit in and ignore this data way over here on the left. And the same can be true on the right symmetrically. So now that fills up the screen a little bit more. There's a lot of data below the value 1 that I really don't want. So we can change the range on the bottom and clip off the bottom. In fact, I want to go even a little farther, all the way up to starting at the value 1.1, I think it is, yeah. And work with the data that way. We'll see why here in a moment. We can, to review then, I removed the low frequencies down here. I removed the high frequencies down here. And all these low values, a darker blue, I'm simply not plotting. It's like filling this bucket up with water and now have the coastline higher, close around this green edge. Sure enough, that's what makes it look like islands. We can put contour values, contour lines on those colorful values. And then, of course, we can present it in 3D and tilt it. And once we do that, we can move the camera a little bit to the right. And yeah, they really do look like islands. If I tilt it again 1/10 of a radian to the right, that's about 5 degrees. I can do that a couple of times. Gosh, if I have a whole bunch of those all the way around the circle, I could make a movie. And while I'm at it, let's make it a stereo, cross-eyed stereo movie. So that's what we're doing here with an easy GIF on the web. We'll glue all those things into one presentation file. If you hold your thumb about 5 inches from your nose and focus on your thumb with both eyes, you might see in the background a third image in the middle, and then concentrate on that. That's cross-eyed stereo, so that we can see this image now in stereo, even if it's moving. What has this got to do with radio astronomy? I'm not quite sure, but it makes dramatic images and videos, and that might attract folks and get them to ask more questions about what the heck are you doing? That's really pretty colors. And It looks neat. What does it mean? And then you can start talking about all those technical details that we savor. The Ezra software is posted up on the Ezra webpage. On that webpage, I have a bunch of new links rather recently talking about how you do some of these 3D plots. And even at the bottom, there's a new paragraph down here emphasizing more about sharing the data that we have between ourselves. I can't see all of the radio sky from my location on Earth. Maybe other folks can't see that parts that I can see. So let's share data back and forth and get a more complete image of the sky. All of that there is on the Ezra webpage. After that, all that, any questions? Very good. Thanks to Dr. Andy for helping me get that shoes webpage up.
All right. Okay, thanks. Let's go to Jason, our resident professional.
All right. I got a couple of things. So I did manage to get my dish repaired after after its trip out here. This is it. And I did manage to last weekend, actually last Sunday and Monday afternoons, I was able to get 2 successful drift scans of M31. And then I was set up on Tuesday afternoon to try to get a scan of M31. And I set it up over my lunch break and then went back to work. And when I came back, the wind had blown it over and busted it again. So I got to do more repairs. But I did get some decent data. So I'll go ahead and share my screen here and do a little of that. Okay, here we go.
So while you're doing that, explain M31 to some of the new people.
So M31 is the Andromeda Galaxy. It's our closest galactic neighbor. It's about 2.5 million light years away. And then M33 is the Triangulum Galaxy, which is also in that same system. It's a little bit of a smaller spiral galaxy, and it's also in about that same distance range. And so those are our 2 closest neighbors. And they're also the 2 that are possible to detect with a small dish in the hydrogen line. It's tricky, but it's actually possible. I presented a paper in August on detecting some of these external galaxies outside of the Milky Way using a small dish. I was going to go ahead and show, let's see, here was my setup last Sunday. Hopefully I've got it. Let's see. Is it opening? Here we go. All right. There we go. Okay, so here's the desk in the guest house where I've been staying since I've gotten here, and you can see through the window the dish set up right outside the window. And there's my SDR mounted on the heatsink to stabilize it. And then I got my USB cable running in. Got a photo looking towards the window that you just saw in the previous picture, and that's the dish set up out in the backyard. My feed, and this is something, I might send you some photos of this, Andrew. I did make a Cantenna feed to start with, but I found that a loop feed was easier to make and it performed just as well. If you're interested, I could send you some photos of that as well, some close-ups and
I would love to see that. I'll put my email address on the chat now.
All right, cool. Yeah, I had to patch several of these ribs. They had broken, and then several of my zip ties had actually broken. because of the extremely cold weather on the drive across the country, and they just got brittle, and so I had to repair those. But this is set up to do drift scans of M33, and there's my setup a little bit closer. Look at my setup. That's not it. Okay, where is it? Okay, there we go. So this was, that was actually not, this was what I captured Sunday evening or Sunday afternoon. It's a little bit messy because it's just a single day's worth, but, and also I did have a little bit of problems with trees right up next to me, so I was probably getting some thermal noise interference as well, but definitely can see some activity in the right range. So that, yes, is my observation. Oh, okay, so here's a picture of just the raw data. So the blue line is what my raw plot looks like, just coming straight out of the data analysis. And then I did a curve fit to flatten it, and then the orange is after it's flattened to correct for the sloping response of the receiver. And you can definitely see the two prominent bumps here, right in the right spectral range for the spectrum of M33. For those of you that aren't familiar, this hydrogen line is a single emission line, so it would essentially be, if you were looking at hydrogen, if you could look at the hydrogen line signal from like a big tank of gas in a laboratory, which is not really possible, but if you could, you would see a single narrow peak at 1420 megahertz. But what happens is when you're looking at sources, especially galaxies outside the Milky Way, they're moving with respect to us. And so the Doppler shift causes that peak to shift in frequency, and it allows you to measure the velocity, the relative velocity with respect to our position. And in the case of looking at a spiral galaxy, because it's moving, but it's also spinning, you actually get a single peak that's split into two. And so you usually see two peaks, because one side is moving towards us and one side is moving away from us because of the spin of the disk. And so that's what you're seeing here. This is an example of something. So there's been a discussion going on this week with Edvard from the Netherlands, who's been doing some similar things to what I'd been doing earlier in the year. And Wolfgang from Germany had put a link to survey data for hydrogen line, and mainly it's for Milky Way, but it's a full sky survey in hydrogen line. And what we found is that if you take that data and you set up the coordinates that you're looking at in that data, and you set your simulated beam width, you can basically type in a beam width that you want to simulate from that data set, and you can type in a coordinate, and it'll give you a spectral profile that you can download. And so what I did was I actually downloaded spectral profiles for a simulated drift scan like I was doing with my dish. And so I did the coordinates for when I was on target, the coordinates before, basically one beam width off, ahead and behind. And then I took those three data sets and did the same math that I did with my actual data to see if the simulation from that survey data would give me a similar result to what I was seeing. And so here's what the simulation looked like from this survey data. And here, let's go back to where, and then I'll show you what my actual data looked like. Okay, why is it? No, that's not it. So this is what my actual data looked like. So you can definitely see the simulation looks very similar. You can see this peak just around minus 100 kilometers a second, and a peak between minus 250 and 275. And if we go back to my actual data, we're around minus 100 and between minus 250 and 275 with this flat in between. So you're seeing that in the other cool thing is the simulation is giving us data it's in temperatures in kelvins, which doesn't really matter. What I'm more looking at is what the relative strength is compared to mine. And then I can use that because I know, okay, I know that M33 was detectable. I know what size it was, what the strength of the signal was. And so then I can look at other things that I'm planning to try to observe, and I can use the same settings and get an idea of what my expected relative strength will be compared to other things that I've observed. So it gives me a way to gauge or calibrate my observations. That's what I've got so far as far as observations. The only other thing I wanted to mention briefly is that we have been at the VLA have been in A configuration, which is the largest and most spread out configuration. So the dishes are spread out over the entire track all the way out to those arms in the Y pattern are 13 miles long on the east and west arms and 11 miles long on the north arm. And so since October, we've been in A configuration. And so those dishes have been spread out over basically 22.5 miles worth of space. Now, starting this coming week, they're going to be reconfiguring the array into D configuration, which was the smallest and most compact. And so when you guys come out for the Western Conference, it will be established in D configuration. And so the good thing is that means all the dishes will be relatively close into the visitor center. So it'll be really impressive and you'll be able to see them all very quickly in one panoramic view. So I do have images of the configurations here. So this is the biggest, zoomed all the way out to where you can see the entire thing. So the pink is A configuration positions, and then B configuration is the orange, and then the yellow is C configuration, and then D is all the way in at the center. And then there's a more zoomed in version. So this shows now where the visitor center is. So where I have marked with this little arrow is the antenna that we will be able to walk right up to. We won't be able to go inside the fence, but we will be able to get right up underneath it to where you can actually see it over your head almost. And you'll be able to see a lot of the features really clearly. That one never moves. It always stays in place. That pad is occupied in all 4 configurations. And so anyway, just whetting your appetite for some things you'll get to see when you come out here in March. And that's all I got for today. Any comments or questions?
Can you explain why they changed the configurations, the highest resolution and lowest resolution, and what that does to
yeah, so the largest configuration where they're spread out over the widest area gives them the highest angular resolution, because it basically means you can see smaller details in the sky. The spatial resolution of an optical system or a radio interferometer are both directly related to how large the aperture is in the wavelength, and inversely related to the wavelength. So if you got a bigger aperture, you get more detail, but you also trade sensitivity. And so changing the configurations to a smaller aperture and a larger aperture allows them to create composite images where they can see fine detail, but they can also see large scale structures, and they can overlay those, and then they can get a complete picture. That's a very simplified explanation, but it's accurate. Yes.
Excellent. All right. Any
Hey,
questions?
quick, that deconfiguration, Jason, is that, oh, it's a half mile, isn't it? That's what it's over?
It's just over a half mile. I think it's about 0.65 miles, something like that. So it's almost 3/4 of a mile across. Yeah.
All right. Okay. Lisa, now we got you on. What do you got going on?
Mute. Here we go. Not a whole lot. I finally figured out how to get on and participate in the Zoom meetings now here. I am actually still in Indiana. Jason's in Socorro, so we're hoping to correct that in the next few months. I've got a house I'm selling, and I am moving to New Mexico as well. So that's really great. And yeah, looking forward to the conference coming up. I've got work obligations, so I'll be in here in Indiana, but I just signed up for online, so I'm really looking forward to that.
All right. And it'll be warm enough for you guys to wear your kilts more often, I think, too. So
Yeah.
just a thought. All right. Thank you, guys. Rick, P0GD.
Yes, hello.
There you go.
Here. Too many buttons to push. I've been keeping busy with my own antenna feed problems. And this little fellow that I'm trying to characterize for our dish to see if we want to use it. It's all ready to be installed. It's 400-ish megahertz, 408 megahertz and up. Patch antenna with 2 feeds for vertical and horizontal, and a combiner on the back that allows us to select left, horizontal, or vertical remotely. And we want to put that in the 60-foot dish. We've been experimenting with pulsar detection at 250, 300, 450 or 400 megahertz area, and 1296 and 1400, and a bunch of different frequencies, because different pulsars are more easily detected at different frequencies, we think. Anyway, it's been a lot of fun to experiment. If anyone is interested, just today we posted the annual report of the things we did in 2024 on the dses.science website. It's a very long list of things we accomplished. It's probably the most productive year DSES has ever had. We've done a lot of work. So I think that's all I have right now. We did detect our first magnetar with our dish a month or so ago. That was fun. And we are preparing in a few months. Our equipment is all built and ready to be tested for our Venus-Earth bounce experiment. We'll be putting a couple of kilowatts into the 60-foot dish at 1296 in an attempt to communicate with other 60-foot dishes around the world in a two-way digital communications off Venus, which I don't think has ever been done before. And we'll see if we make it or not. Our link margin is very tight. So we'll see. We might make it. We got our 2 kilowatt amplifier and our LNA and our antenna feed all built and ready to be installed for testing in a few weeks. So we're keeping busy down here in Colorado.
All right. Anybody got any questions for the DSES team and Rick?
What frequency was that Venus bounce off?
The Venus bounce will be in the 1296 band. I can't tell you exactly what frequency just at the moment, but it will be published well in advance.
All right. Anything else? So if anybody's ever in Colorado and wants to go down to the site, let me know, and I'll hook you up with the DSES team if you want. Okay. Thanks, Rick. Good job. Jameson Adcock.
Hey, how's it going? No observations to report, but I did want to give a little bit of an update on the Smithsonian. I've been in touch with them. I was going to try and meet up with them yesterday, but my son had a recital. I'm going to reschedule hopefully to next weekend, but apparently they have something that's working well enough that they can show to the public, but there are a few kinks that they need some help working out. So hopefully next Saturday, I'll be able to meet up with them. And that's pretty much it.
And for everybody's knowledge, Jameson is our Smithsonian representative.
I'm offering support to the Smithsonian. I'm not connected to them, but
oh yeah, he volunteered to help them. I think they got do they have the itty bitty telescope, a super SIDS, and a
scope in
the box.
Yeah, and I think that's the one that they have it working, but they said there was an issue with the plug-in. I don't have more detail than that, but I think the best thing just to do is go down there, meet up with them when they're doing their public demonstration, and see what the issue is.
Yeah. All right. So we're getting some notice. Get some Sarah stickers or something to give to them too. Let's see. Stanley Corin.
Oh, hello everybody. Got an audio check there? Am I good?
Yeah, you're good.
Okay, thanks. Nice to meet everybody. I'm new on I've been following Sarah for about 2 years, a member as well. I work at a university that has been going through restructuring with their astronomy program in physics. And as a result, while we were trying to move into radio astronomy as well, and working on a micro credential now. I'm from Sudbury, Canada. I don't know, I haven't met everybody here before, but our claim to fame is that we've got 3 meteorite impact sites. Apollo astronauts visited here for a geology lesson in the, I guess it was 16 and 17 Apollo missions. And like the founder of our planetarium, we have a planetarium as well as a scope on the roof of our physics building, which we use for demos. But he actually worked for the Apollo missions, and he had these big photographic plates that he would set up. And it was, as Sudbury was a sort of a northern outpost, it was a dark place. He was able to track the early orbits of the Apollo, I guess, pre-flight, and send these down to, I guess we'd send them down to Houston directly. We'd have DC-9 flights from Sudbury going down to Houston. Some of the work I did, mostly visual, but we were working on a hydrogen line antenna, and we have the setup. It's still in progress, but I guess I've gone a different route, being more into ham radio HF. We actually built a Yagi, believe it or not, and it was probably about 18 or 20. I think it was actually 24 elements. We're pretty adamant to get it working, so we got a 24 element the H line 1.4 gigahertz a Yagi. It was copper wire and wood, and we have it set up with our preamp, and we just have to get the LNA working with our preamp now. So we're getting closer. It's probably, we'll see what we get. But it's been great to hear all the presentations, and thanks for doing the net. Thanks for having this online. Much appreciated.
Great, and I hope you get on our Sarah forum and present your design, because we have a lot of people that have done this before and can help you get that hooked up and working. And then a lot of good software products that give you all sorts of results.
Okay.
So,
Okay, great. Thank you. Yeah, on the forum, on Sarah Forum. Okay, I'll check that out. Much
Okay.
appreciated.
Thanks. And yeah, good job. Let's see, Johnny Cox.
Okay, had to unmute. I don't have anything stellar to report other than the same stuff I've talked about before. I live in South Carolina, and I have a terminated folded dipole square array. I got 3 receivers. I got 2 radio Jove receivers that receive at 20.1 megahertz, and it splits into right and left circular polarization using a hybrid ring. And I have that running continuously. And then I've got a RSP1A receiver, and it's connected to a spectrograph 17 to 24 megahertz. Had a good Jupiter season, gotten quite a lot of emissions from Jupiter this season. That's winding down now. But the sun is waking up again, so most days to get solar collections, which has been fun. But that's about it. And I appreciate all of your expertise.
We realize we're having a joint Radio Jove Sarah meeting for the Eastern Conference. I would love to have some of your observation results on your Jupiter stuff presented there, or even in the journal earlier than that. You've got a place to put the results, and go ahead and give them to us. We're haven't seen a lot of Radio Jupiter stuff in my journal lately, so I'd love to get some.
I put it, I can't figure out whether people enjoy what I do, but each evening during the Jupiter season, I put it all together and attach it to an email and send it out so everybody can see it. And I think it helps everybody to see it, what it looks like, and we compare notes, and I think it's good. And I have all that stuff in my computer, so I've got all the data's there, so I just need to know what kind of format on how to put that together or how to get it to you.
I would say just, are you on the forum yet, the Sarah forum?
I don't, apparently not, because that's not familiar to my ears.
I think, let's see, Ted, you got a link to the Sarah forum you can put in chat, and you post it there, and people all over the world will view it and make comments and request more and all sorts of things.
That's easy. I can start. I can go back and put my better Jupiter emissions out and attach them, because it's all there, several years worth.
Yeah, just put out one and ask them how people like it. Is it the right format? Can they understand? And then start the dialogue, and you give them as much data as they want after that.
Okay. Well, that sounds good. I appreciate that.
Yeah. Glad to have you on. And yeah, I think Eastern Conference is in West Virginia at the Green Bank.
Yeah, I plan to be there.
Yeah. Sound like be great to have you there as a presenter.
Oh, that kind of scares my soul. So be gentle with me.
That's okay.
And tell me what I need to do.
We're very easy. We're a fun group. Okay.
Thank you.
Thank you, Johnny. Let's see. Where am I going here? Rich Kraling. Pronounce that right?
Yes, you did. I'm just honestly enjoying all the conversation and trying to learn.
Good. That's where you're located, and what are you thinking about for your first radio telescope?
be in North Central Ohio and haven't looking to do the Astronomical League's radio astronomy program, and so I have not yet picked the first project, to be honest.
I would say the Meteor. Are you a ham?
No, I'm not.
Oh, okay. I'd say between Radio Jove, Meteor, Super SIDS, well, even now with the amount of software we've got and everything, the hydrogen is actually relatively easy too. But yeah, I think you can easily get the Astro League's gold with the stuff you're just going to learn on these Zoom meetings.
Okay.
Yeah.
So
Just a word of warning.
Get on the forum and ask questions.
Yeah, just a word of warning. If you get into hydrogen, you'll get sucked in. It's
never leave, huh? That is true. That's true. This is just, you can never have a big enough telescope, and you can never have and once you think you know something, somebody will come by and convince you that you don't, and you have to go get something else.
Yeah, of course.
Yeah. So it's fun stuff. Okay, glad to have you. And yeah, get on the forum. Everybody who hasn't been on the forum, get on the forum. And it's a 24/7 radio astronomy help desk. All these guys are on the forum all the time, and they'll help you present your data and let them beat it up and help you improve it.
Awesome. Thanks.
Okay. Charles Osborne, our historian.
Yeah. Hi, Rich. Okay. How's my audio?
Good.
Good. Okay. Not too much to report. I am going to try to come out to the VLA meetings, working towards doing that if life doesn't get in the way. That's about it for me.
Okay. Thanks. All right. Now that I've got the entire group here. Tom, our distinguished treasurer. I'm giving you guys distinguished. Great, because you're.
I had to unmute there. It spot when I started talking, it told me I needed to do that. Yes, Tom, the treasurer, and I saw earlier someone was asking about when would registration for the Eastern Conference open up, and that will be probably sometime after the Western Conference is completed, since there are a large number of people in common between the two groups. So that may not be a while yet, but it will happen and soon, or at least sometime in the near future, I hope. The next thing to say is that yes, the website was out of service sometime over the midnight hours. I believe Chip has finished doing that, or at least the website is back up and somewhat and vastly different. So if people want, they can go and they can look there and look around. And if you see things that are wrong, because I do know there are some things there that need to be updated, make a note to either me or to the webmaster about things that are in need of effort there. I'll also say about the Western Conference. The last time I looked, I think we have 18 people registered, and that splits pretty evenly between online and in-person people. So that's it. If you have any questions, you can write me at treasurer@radio-astronomy.org. That's probably the best way to do it. And I'll let it go with that unless people have questions, and then I'll do my best to try to answer them.
Sir, would you mind putting that your address in the chat, please?
I will put the treasurer, there's an alias that goes to the treasurer, and I'll put that in the chat, but that's also on the website. But it really is treasurer@radio-astronomy.org. And right now I can't really type that because of the way I'm working here, but I'll do that hopefully before the meeting ends. But any other questions?
All All right. Okay. Thanks, Tom. Bob Strickland, a board member.
I just don't have a lot to say. I've been working on camera stuff for my meteor detection things. Recently, I've got these boxes that I buy from China, and the little cameras are about $30, and I'm using Raspberry Pi 4, and I've been working on 3D printed plastic parts to put the Pi and the camera in there and improve that assembly process a little bit so it makes a complete unit for capturing the meteors. And that's what I've been focusing on lately. So back to you, Rich.
All right. And I'm still impressed about your AI camera there that's zooming in and out automatically. And speaking of that, there's been a lot of discussion about using ChatGPT for radio astronomy analysis. Start thinking about that, because I think that's going to be the next. We got all this data that we're collecting, and a lot of people collect, and I think if Pablo came up with a way to look at that data and maybe derive other sources and other things that you normally don't have, because there's so much data, and the Chat GPT can be configured to analyze the radio astronomy data we're collecting. So start thinking. Anybody wants to get interested in the AI part of this, we're looking for a group that wants to play with the Chat GPT. I think I hook you up with Pablo, and he's got some stuff, and other people have been asked on the forum, have been looking at it. Think about that. And Bob, I don't think you're using Chat GPT for your camera, but it's still cool the way it zooms in and out on you.
Yeah, the astronomy on the meteor detection, the global meteor network is using AI to separate the airplanes from the meteors. And so that they generated a data set to teach the AI engine what it is that what the meteor looks like versus what an airplane looks like. And so there is a model there that somebody could look at to help guide you in how to go about accomplishing that. And that was all done in Python, and it's all open source type things. So it's a way to get into this aspect.
All right. This is good stuff. Okay. AC.
Yes, hi. I came in a little bit late earlier today on the Zoom here, and caught the tail end of the feed discussion. I'm trying to get started and setting up a system, and that's one of the things I've been looking at. So I've been on the on the forum, and there's been a lot of people that have helped with some discussions and whatnot. So I would like to appreciate their help and thank them for it. But that's about it. Just trying to get going and looking at the different aspects of setting up the telescope, and that's pretty much it.
Okay. Questions for AC? All right. Bruce, our treasurer, or excuse me, our secretary. Bruce, you there?
Bruce is on mute.
There you go.
Okay, am I in there?
Yep.
Okay. Yeah, okay. First, I just went through cataract surgery, and now getting my eyesight back, and I went through the left eye. So I don't know if some of the others have maybe been through that. But among other things, it keeps me out of my workshop because you can't do any drilling, cutting, or anything else where you're likely to get, a little speck of dust or something in the eye before it heals. So that's kept me out of the workshop. But one of the things I did do some measurements on a while back, I'm looking at signal combiners for 20 megahertz between two antennas for solar flares and Jupiter emissions there. And the problem I've got is I've got active antennas with preamps inside of them, and I've only got one of them in operation now, and it works reasonably well considering the size of it and space and everything. Wanted to get a second one. I need a combiner. And I started looking at combiners, buying a few off of eBay, things that say this splitter, which you should be able to use reverse as a combiner, has got 5 to 2,000 megahertz bandwidth, which is maybe a little horse manure, I don't know. But anyway, start measuring things like that in the lab, and you find there's almost no isolation between ports, very bad mismatch in SWR in the ports. Tried several of the ones, but they got glowing stuff on the packaging, like quality video accessories, and it's digital, despite the fact that it's really analog. And took one of them apart and found that it had the splitter, but didn't have the transformer to scale the impedance back up. So when you combine two 75 ohm cables, you get a 37 ohm output impedance, and just all kinds of nonsense with those splitters. So I looked, okay, let's make my own splitter using a few small toroid cores and a wire. And splitter would be fairly easy to make until you get to the fact that DC is going through it. And as soon as you have DC feeding the preamps going through it, now the transformer cores are going to at least move around and try to saturate on you. So I've been going through a lot of math modeling on that, trying to figure out how to make something that works without building too many things that won't, because again, I'm restricted from my workshop, and then I'll be getting the other eye done shortly. Again, I'll be a few weeks out of the workshop, so that keeps me from getting in and drilling and cutting. So that's where I am. Eye surgery. By the way, the left eye is finally getting better and sees better than it ever did. I got color vision back, but that's where I am right now. It's the eye surgery. Long term, it's going to be good, but boy, it's a pain in the butt short term. I guess that's about it for here.
All right. Any questions for Bruce, even on cataract surgery for us old guys?
Well, I've had both eyes done, so I know where he's coming from, but it does get better. And I don't.
Yeah, go ahead.
I was going to say I don't have to wear glasses to drive now, but I do have to wear reading glasses, which is not a big deal.
Yeah, I was going to make a comment that I've had both of mine done in the last few years, and it made a huge difference. I had horrible vision since I was in 4th grade, and now I just have to have vision glasses just to drive for reading, and that is it. I can see close, and it's really great. I paid for that upgrade. But yeah, the thing that got me is they told me don't rub your eyes for like a month. But yeah, glad you got that taken care of, Bruce. That's really awesome.
The doctor did it. Actually, the regular eye doctor who's working with a surgeon who did it, but they had the eye doctor knows about me and said, just stay the heck out of your workshop. You don't want solder flux from soldering getting in your eye or anything else. So yeah, it's pretty restrictive. And my vision was very bad for almost a week after they did it. It was real blurry. The blurring began to clear a little bit at the outer edges, and finally that eye is seeing better than it saw before. And like I said, the color vision is truly amazing, because the lens, of course, was yellow before, but enough for cataracts. I am going to go ahead with the other eye. Like I said, the first one, it was pretty scary to start with, because it was more than a week before I could see about anything.
Wow. It's good you're a radio astronomer. All right. David Kunzman.
Hello. Nothing really new to report. I'm still in the process of ordering a Super SIG, because that's probably going to be my first project. And just got access to the 20 meter remote. So I'm reading the tutorials on that to learn how to make observations on that. And one more question. I see a lot of presentations of people making dishes, but has there been any horn designs recently? Because I was thinking about maybe doing that, trying to make a horn.
Somebody did make a horn just a couple of months ago and presented that. And I don't know if anybody got links to the horn videos. I'll let him know. Are you thinking about using a horn as a primary receiver, a primary antenna, or a feed?
Yeah, a primary.
Yeah, they work pretty well. We had one guy out on the Eastern Conference that just handheld his horn. He had beautiful signal up the galaxy. So, and he made it with cardboard and aluminum foil, I believe, as the somewhere we've got it. And I don't know, see if you guys can find it on the link. Yeah, go to the forum and maybe somebody will find it on the forum.
I saw the on the website in the section about antennas. There's a link to the Horn of Plenty, I believe, from SETI League. And I was thinking about maybe trying to copy that design.
There's a horn antenna. What is it? Tennessee State, or I've forgotten.
I just posted about West
a link
Virginia.
to. Ted just posted a link to West Virginia University's.
That's the one. That's the one.
Yeah, that's
Ted,
a good.
Ted, you're just amazing. Absolutely amazing.
Comment on horn antennas that in my career before I retired, I did a lot of EMI testing on stuff at test labs for products I'd been involved in the design of. And if you find frequencies above 1 gigahertz in the test labs, I almost exclusively use horn antennas. And a significant factor in that is that they tend to have a very clean pattern. I mean, you try to make a parabola with a feed of some kind, feeding it, and you get scatter at the edges, spillover, all those effects, and they're about nil with the horn. Disadvantage of the horn is it's a lot more material to put together for a given amount of collecting area. But as far as cleanliness and not picking up interference and stuff, I think they're about the best you can do.
Yeah, that's what you and Purcell used to detect the hydrogen line at the very beginning when nobody thought it was possible.
No, that was, it's not a horn. Oh God, not again. It's a covered path, but it's actually a parabola sector. If you look at the back end of it, but it has the path from the sector horn, from the sector dish, is covered into a horn. Yeah, that's not a horn. That's a horn. That's not a horn. That's a horn. Is that the same thing?
The first one looks like a corner antenna.
It's a corner reflector.
Right.
Not a very.
Second one's a horn.
It's not gonna. The corner reflector is not gonna work very well.
I'm just pointing out all these things do work.
Yeah.
I wouldn't worry about your design. Mostly it's just putting a little stick out there. Remember, a dipole will pick up hydrogen all by itself. So good luck. The key is to do it and not think about it for so long. Good luck.
All right. Did you get enough? You get too much information there, or enough, or?
No, that's good information. I'll look at the link that was posted in the chat.
All right, great. And as I was saying, get on the forum and present your results, and people help you along. All right, did I miss anybody? All right, any last comments? All right, Drake's Lounge in 2 weeks. See everybody.